morning, guys. My name is David Page. I'm with Fast Fuel Injection Systems, and we're located in Memphis, Tennessee. A part of the Sir, you couldn't? Thought I need to clear that up in case you were wondering about my accent. We're part of the Comp Performance Group. So today I want to talk to you a little bit about a system that we introduced at SEMA this year. This is the XFI Sportsman system. It's an evolution of our professional level XFI ECU that we really started looking at our market, and we started seeing that there were a lot of muscle cars, hot rods that were using higher and higher performance engines that didn't necessarily need our professional level system, but they needed something that can control an engine with a supercharger, turbo, nitrous oxide, or that they want to do some real fine tuning on. So we took that idea and developed it into this XFI Sportsman system. So this is an easy to use, programmable, and custom tunable system. It has all the self-learning features of our Easy EFI and our Easy 2.0 system. But on top of that, those systems are designed to be used with a handheld programmer only. So all your changes to the tuning and to the setup are made through the handheld programmer. The XFI Sportsman includes a full software package so that you can go in and make changes. You can set it up for boost, set it up for nitrous oxide, or any other use that you have for your particular vehicle. Utilizes our proven fast CCOM software. It's a perfect fit in between our entry-level system and our professional level system. What we begin to see is that people are building muscle cars and street rods with really high horsepower, large cubic inch engines. Crate motors are boring now. Nobody wants to put a stock crate motor in their hot rod. They want to have some horsepower. And this system fits the need of that level of engine. Utilizes both speed density and alpha N strategies. Supports naturally aspirated, boosted, and nitrous applications. It'll work with a LS style engine with a coil-on plug setup or a traditional distributor type application. Controls both fuel and spark, and it's compatible with either a multi-port system or with our throttle body injection system. We'll talk a little bit more about the difference between those two in just a moment. So the top picture there is a picture of the base system, the ECU, the wiring harness, wideband oxygen sensor that goes in the exhaust, as well as a fuel pressure sensor that goes in line so you can monitor your fuel pressure. The bottom picture is an example of a multi-port setup. So multi-port meaning one injector in each intake port, one injector per cylinder. The throttle body sitting on top is just flowing air. It's only controlling air in this case. So the base kit's compatible with up to a 5-bar map sensor. In layman's terms, that means it can work with up to 60 pounds of boost. It's waterproof. As I said, the fuel pressure sensor is included. It's designed for muscle car, late model, boosted, individual runner setups such as our English setup or a converted Hillborn old style setup that's been converted to EFI. It can control those systems. Compatible with pump gas, race gas, alcohol, or E85. And please stop me if there's any questions or if I say anything you don't understand. This is a small group. We can discussions are welcome. So the top is a picture of our Easy 2.0 throttle body. This is a carburetor replacement unit with 8 injectors inside the throttle body. The injectors are positioned and located to provide really good atomization of the fuel below the throttle plates, so they provide really good even cylinder-cylinder distribution from a throttle body unit. So if you want to use a carburetor style manifold and you don't want to modify your existing manifold, that throttle body is a good complement to this ECU. So again, your choices would be, if you're converting a system from an engine from a carburetor, you could either go with that throttle body, or you could go with an intake like pictured in the bottom here, where you have an air-only throttle body and the injectors in each port. This just shows an example of optional fuel systems. Now the throttle body you see at the top there's enough fuel capacity here to support 1,200 horsepower. There's 8 85-pound-an-hour injectors in that throttle body. The injectors are the only limitation. The ECU doesn't know or care how much horsepower you're making. So if you're making more horsepower than that can support, you just need enough injector. But in the real world, 1,200 horsepower pretty much covers all bases. Now, the way the system works is it only operates off of 4 of the injectors until a certain duty cycle, and then it brings in the other 4. So you're not overfueling or not trying to control an excessive amount of fuel. Fuel pumps, your fuel system also needs to be sized to however much horsepower you're making. That's the only deciding factor, and also the fuel type as well. Alcohol obviously is going to need about twice the amount of fuel capacity as gasoline would. And we also offer fuel hose kits, so we can put together a package that has everything you need from the fuel pump, all the fuel lines, regulator, throttle body, and of course all the electronics. Yes, sir. Absolutely. Yes. Yeah, we've got a lot of customers doing that. So you can put 2 of those, we'll back up here. You can put 2 of those throttle bodies on top of a root style blower and use the XFI Sportsman controller to control it. That's actually become, we've done that for so many customers, we're building a kit that's specifically for that. Mm-hmm. This is our E-Dash. The E-Dash is approximately the size of a large smartphone or a Garmin GPS, and it'll display all of the engine information, and you can also make tuning changes through this dashboard. So you can put it on your dash, suction cup mount to the windshield just like you would a Garmin GPS, or you can hold it in your hand. You can permanently mount it, but it'll display all the ECU information. In this picture, you've got RPM, injector duty cycle, you got your fuel pressure, air fuel ratio, boost pressure if you're using boost, coolant temperature, and battery voltage. You can change the screens and display even more data, but this is just there's 3 different screens that you can choose from. No, it's actually got a communication cable. So here's some of the technical basics for the XFI Sportsman. It's a backfire injection strategy, works with either a throttle body or multi-port application. Works with all camshafts, including low vacuum, because with this system, you can go into alpha N mode. And I probably should explain that a little bit. With a typical speed density EFI system, it uses manifold vacuum to measure the load. Anybody remember in the early 70s, there were economy gauges. And I worked on a 65 Impala that actually had one from the factory. There's a big vacuum gauge right in the middle of the dash. So you step on the gas and all the vacuum goes away, and it tells you poor economy. You let off the gas and the vacuum comes back, it's good economy. And if anybody ever had a vehicle with vacuum operated wipers, you step on the gas to take off from a red light and your wipers stop. And then you let off the gas and they start moving again. So basically what that tells us is the load on the engine, the vacuum in the manifold is a real good measure. You step on the gas, basically the motor consumes all the air it can take and there's no vacuum, so it's maximum load. But if it's idling, the engine's pulling more air than the throttle body can feed, so you're pulling a vacuum. That's light load. All modern EFI systems use this. But there's an alternate way to do it. Alpha N uses throttle position as the measure of load on the engine. So say if you're driving down flat road and you're at a steady speed and steady throttle and not using cruise control, if you come up to a hill, what do you have to do to throttle to maintain the same speed? Give it more throttle. So TPS is actually, in most cases, a pretty good measure of load. If you want to go the same speed, if it takes more throttle, then you got more load. You're either pulling more load or you're going up an incline. So alpha N is an alternate method. The problem is if you have a really big camshaft, you don't have much vacuum at idle. Most people know that if you ever tried to use power brakes with a big over-cammed engine or a large cam engine. So that causes a lot of problem with speed density because the computer doesn't see much difference between idle and wide open throttle. So when you're idling, it's not making any vacuum. The computer can think you're under 60, 70% load and it overfuels. Alpha N fixes that problem because it's full, it's all off a throttle position. So you can use any camshaft you want, full race engine. Most full race applications use the Alpha N strategy. When we brought out the XFI Sportsman, it really opened up that ECU to be able to control a lot of applications that were troublesome for a speed density or traditional EFI system. Individual runner setups are also something that's difficult for speed density because you've got 8 stacks to each port, and it's very difficult to get a common vacuum signal. Some people try to make a manifold with hoses going to it, but that can be a problem as well because instead of a nice steady vacuum signal, it's very pulsy. So again, that's another application where Alpha N comes in and covers all sins, so to speak. So, and this, again, we're seeing more and more. Well, you walk out into the hall and everybody's using their imagination to come up with the wildest combination they can, something different, something new. And this system is adaptable to take care of whatever somebody can dream up. Works with any high impedance injectors. The enclosure is waterproof. It has a true limp mode. So if every sensor can fail except for the RPM signal. As long as it's getting an RPM signal, it'll go into limp mode and get you home. The E-dash that we saw a minute ago, it's optional as a live engine data scanner. Basically, where with OBD style modern vehicles, you plug in, it gives you a code, but now you can actually plug in, instead of getting a code, you're actually seeing the engine data. And if there is an error, sets the error code, instead of having to look the code up, you can simply scroll to the screen. It'll tell you exactly what sensor is outside of normal parameters or where it should be. It's nitrous and boost capable. The handheld can be mounted like an electronic dash. Uses a Bosch wideband O2 sensor. Is everybody familiar with the wideband O2 sensor and the difference between that and the narrow band? So basically, a narrowband sensor is only accurate over a narrow band, as it says, which is near stoichiometric ratio, 14.7 to 1 air fuel. And that's fine for a factory vehicle, or in the past it was anyway, because they operate under a very narrow range. High performance engines have to operate over a wider range. Therefore, you need a sensor that can read from very rich to very lean conditions, especially since it's using the feedback from that sensor to tune the engine and make changes. So if it's way off, it needs to know where it is so then it knows what to do to correct it. There's an optional AC input that'll trigger bumped up idle speed when the air conditioner is activated. There's obviously electric fan and fuel pump output. So to the car builder, that means you don't need an additional temperature switch to turn on your fans, because the coolant sensor the ECU is already using can trigger the fans. And instead of having a preset switch, you can program what temperature you want the fans to turn on and then turn back off. Installation tips. Fast or equivalent CD ignition with a TAC output. We have fuel systems. You can use an existing EFI system as long as it'll provide the amount of fuel that you need at the operating pressure you need. There's no specific requirements on fuel systems, but we do offer complete systems. It's compatible with return or returnless fuel systems. Compatible for use with wet nitrous. Compatible with flex fuels, including E85. It does feature the adaptive learn technology that's been proven in the Easy EFI and the Easy EFI 2.0 system. So you don't have to do all the tuning. You can turn on the features. You can set parameters so that it can learn in a certain area but not in another area as far as RPM and load. So some installation tips. With an EFI system, and when we talk to customers, we hear a statement, well, a ground is a ground. So most people think that grounding to the body is acceptable, grounding to the frame rail is acceptable. And for just running a motor like an electric fan or electric water pump or a fuel pump, that's fine. Because the ground's job in that case is just the return path for the current. But with an EFI system, we're dealing with signals. And those signals have to have a very clean path to return, or we get what's called interference, which can cause a lot of very difficult to diagnose and difficult to fix issues. I think of it like an interstate system. You can take side roads to somewhere and back roads, and every time you come to an intersection, you've got to stop and wait on somebody else to go before you can go. Because ground is just simply a return path. But if the proper way, and the only way we recommend, is grounding directly to the battery, because that's like being on an interstate system that begins at the starting point and ends where you're stopping. There are no interruptions. And that's very important for these signals to return without interruption. A common mistake is to ground to a stud somewhere and then have a cable that goes from that stud to the battery. But that's not the same as grounding directly to the battery, because anything else that's grounded through that source is then possibly can interfere with the return of these signals. So I can't stress enough, probably 50% of our tech calls are solved by moving a ground directly to the battery. Can't stress it enough. The ECU needs to be mounted securely to a grounded metal surface, preferably inside the cab, but you can mount it under the hood or in the engine bay. We were talking about interference, and another consideration is being careful and thoughtful about where you route wires in relation to your spark plug wires, your ignition coil, and your CD ignition box. All these things generate a lot of electrical current, and there's a high possibility to introduce noise, and it can be avoided by simply routing everything independent. Make sure that you don't cross your plug wires or zip tie to a spark plug wire, any of your EFI harness, because you're just asking for trouble to introduce noise into the system. Resistor type spark plugs are highly recommended. I realize that in a lot of applications, high performance applications, there may not be a resistor type plug available in the heat range that you're looking for, but it falls under the umbrella of best practices. You could probably do one or two things that are not recommended in best practices and be fine. But if you do 3 or 4, before you know it, you stack up and you've got an interference problem. It's not that you have to follow each one of these to the T, but you have to be mindful that if you want to perform the best installation, these are the practices you need to follow. Solid core plug wires are absolutely unacceptable. Will not work at all. And frankly, I haven't seen or used a solid core plug wire in a long time. So it's not common, but it is something to be aware of. Take care with the O2 sensor installation. Real important to make sure you don't have any exhaust leaks at all. Because since this sensor is the feedback for the self-tuning, if it has a false lean reading at all, it's gonna incorrectly add fuel to the engine unnecessarily. Got customers who have tried to install a sensor right next to the end of an open header. So what happens there is it gets a false lean reading because of reversion, and it overfuels because it's getting bad information. So it's very important. Now in those cases, there are things you can do. You can put an extension on the collector. You can move the sensor into one of the primaries. There's things you can do to make it work. But it's important to be mindful that you don't want the sensor right next to the opening, because in any system, up till a certain RPM, there's pulses that are actually drawing fresh air back into the exhaust near the end of the header. It's the same situation. The more overlap, the more reversion you have. So big cam plus open header, you're going to get a false lean reading right there at the end of the pipe. It's just like You have one, it's okay. You have the other, it's tolerable. But if you put them together, you got to really be mindful of where you put the sensor. Even a collector leak, right at the collector can be enough to give you a false lean reading. So, real important to make sure you don't have any leaks. So all of our systems are compatible with commonly available GM sensors and Bosch wideband O2 sensors. We obviously carry sensors, but these are all parts you can get at a local parts store. To work with returnal or returnless style, we've got fuel systems available to support. It says 1,000, but actually that's been updated to 1,200. You can support 1,200 horsepower with our higher level fuel pumps. If your engine's not making that, we can select a system, or we can recommend, here's the specs you need. You need this many pounds per hour to take care of your engine. This is a layout of a basic return style system. And this particular system is using one of our in-tank pumps. We were talking about best practices, or I was talking about best practices a minute ago. And an in-tank fuel pump is absolutely the best method because the pump never loses prime as long as there's fuel in the tank. The pump runs cooler, therefore it lasts longer. The pump is quieter. It's a little simpler on the plumbing. Excuse me. And we do offer a retrofit in-tank fuel pump kit that comes with a pump, the wiring, the necessary bulkhead fittings, the pre-filter. Excuse me. So here we see feeding out of the fuel pump goes through a filter, through our fuel pressure sensor adapter. And in this case, this is one of our easy 2.0 throttle bodies. So you feed into one end of the throttle body, and it doesn't matter which. There's a crossover tube internally, and then you turn back out of the opposite fitting on the throttle body, then through a return style regulator. Any questions about that? And also you'll note here, and it's probably worth discussion, there's a vacuum reference line that goes from the throttle body to the fuel pressure regulator. Anybody know what the purpose of that vacuum line is? That's exactly right. This gentleman said to maintain a constant pressure across the injector. So what we have is, if there's vacuum inside the manifold, you've got pressure on top of the injector. When that vacuum goes away, you basically decrease the difference. You can almost think of it like the vacuum is helping to pull the fuel out of the injector. So that is to maintain a constant fuel flow no matter what the pressure is on the bottom of the injector. If you flip it over and think about a boosted application where you got pressure on the bottom of the injector, well, if you don't raise the fuel pressure above the injector, you're basically going to stifle the flow of the fuel. So the increase in fuel pressure is not to provide more fuel. In that case, it's just to provide a constant amount. So it's very important always to have the vacuum line connected to the top of your regulator. Any other questions about plumbing of the fuel system? All right. So this is one of the basic tables out of our CCOM software. It's probably hard to see from where you're sitting, but across the bottom is RPM, and across the vertical scale is load. So that could either be manifold pressure if you're using speed density, or it could be throttle position if you're using the alpha N mode. But basically what we've got here is load on the engine and RPM. So high RPM, high load, that's the highest demand. Now this particular table is spark advance. So these are spark advance numbers. You don't have to curve the distributor. The distributor will be locked out, and your timing curve will be built in this table. So a common question I get is, well, do you have a boost retard feature? And no, we don't, because the actual spark is built off of the boost. It's an integral part. It's not like we command a certain spark and then we correct from it. You just tell it at this much boost in this table, I want this much spark. And the fuel table looks identical. The numbers are just slightly different. Now this is for somebody that wants to go in and do the tuning manually, or needs to hire a tuner to do so. If you turn on the self-learn features, it populates this table for you as it runs and learns. So on the front of the system, you've got LEDs across the front. There's a LED for battery power. There's a separate LED for switched ignition power. I learned the value of that. The first system like this that I installed, it wouldn't crank. Car wouldn't run. And I just happened to look down at the lights, and I noticed that when I went to crank, the switched ignition light went off. So the guy that had wired the system made the classic mistake of hooking to the accessory circuit for the ignition. And everybody knows on an older vehicle anyway, when you go to crank, it kills all the accessories to put maximum power to the ignition. So LEDs paid for themselves that day because we just moved to the switched ignition. And yes. What you'll do is lock the distributor, and you'll set the distributor so the ECU works a little differently. It receives a crank signal from the distributor, obviously if it's locked at the same point. And then it retards or advances the actual occurrence of the spark depending on what you had in that table. So the distributor really is not triggering spark anymore. It's just telling the ECU, I'm at 50, I'm at 50, I'm at 50, I'm at 50. It's just sending a signal to the ECU. The crankshaft is in its reference point. Because the ECU is normally, you go from the distributor to the ignition box. Now you go from the distributor to the ECU to the ignition box. So it relays, it interrupts, so to speak. Does that make sense? Okay. Fuel pressure sensor standard equipment. That's really important because with an ECU, with any electronic fuel injection system, the pressure is, the ECU assumes it's always constant. It assumes the pressure is always wherever you set it. But one of the first things we do in the troubleshooting process, if there's a problem, is verify the fuel pressure. And that's difficult to do if there's not a gauge in the car or a sensor. So we decided to just make it part of the system. So for troubleshooting purposes or for setting your fuel pressure, it's there. Also, if you're using our returnless mode, the sensor is the feedback. So we can either speed up or slow down the pump to maintain pressure. It has to have a sensor to read the pressure. Make sense? And of course, the Bosch wideband sensor standard equipment.